Welcome back and good morning. So, right now it is raining out, so if you hear a little bit of noise in the background, I'm sorry about that. So, this is the solution video for the homework for Chapter 2, Lesson 2, Day 1, Equivalent Ratios. So, remember that at the end of this video, if you feel like you would like some more practice, you can always check out textbook page 197 and 198. That's the independent practice for this lesson, and focus on problems 1 through 8. All right, let's dig right in. So, question number 1, use division to find all the whole number ratios equivalent to each of the following. Circle the simplest form of the ratio. So this is kind of a two-step problem. We need to first, I'll use purple today, find all those whole number ratios, and then step 2, circle that simplest form. So we're using division. So that means I need to think about what numbers are 8 and 36 both divisible by. So I'm going to rewrite this over here just to give myself a little bit more space to work with. And I know they're both even, so I'm going to start with that because that's going to be my easiest bet here. And remember, when using division to find equivalent ratios, you have to divide by the same thing because we want this ratio to not change in value, but just change in the way that it is being written. So 8 divided by 2 is 4, and 36 divided by 2 is 18. Let's see. I'm going to rewrite it again because I know 8 and 36 can both be divisible by 4. So 8 divided by 4 is 2, and 36 divided by 4 is 9. And let's see. If I'm thinking about all of the factors of 8, I know that they are 1 and 8, 2 and 4, and that's it. 36, I know all the factors are 1 and 36, 2 and 18, 3 and 12, 4, 9, and 6 and 6. And so, if we're trying to see which ones they have in common, dividing by 1 is not very helpful. We did dividing by 2. We did dividing by 4. And the only remaining factor for 8 is 8, and that is nowhere to be found in our factors of 36. So that means we are all done with finding all the equivalent ratios, and we need to circle the simplest form. So that means that this is our simplest form, because if we look over here, I'm going to do this with dotted lines, we could continue simplifying this ratio if we wanted to get to 2 to 9, but we will not do that. So we know that's how we know that this here is our simplest form. All right, moving on to question number 2, 12 to 54. So again, I could think of all of my factors that I know for 12 and that I know for 54, but I'm going to save that for the end to see if I miss anything. I do like this idea of starting with the smallest and kind of working our way down from there. So starting by dividing by 2, because they're both even. So 12 divided by 2 is 6. 54 divided by 2 is 27. Now 12 divided by 54, or 12 to 54. I know, let's see, could we divide both of them by 3? I know 12 can be divided by 3, and that's 4. And 54, if I think of this 54 like it's a 30 and a 24, because I know 30 divided by 10, or by 3 is 10, and, ooh, yes, so it can be divided by 3. And 54 divided by 3, well, that's going to be 10, and that's going to be 18. So that's awesome. If we look at 4, can it be divided by 4? So 54, if I was to divide that by 4, I would think of that like a 40 and a 14. And I know 40 can be divided by 4, but 14 cannot. So no to the 4, no to 5, ooh, yes to 6. So I know that 12 to 54, again, can be divided by 6, and that would be 2. Divided by 6, and that would be 9. And that, to me, seems like about all we've got here. So one way, when we look at this, because as our numbers get larger, it's a little bit more difficult to see if you found all of the equivalent ratios. And one way that you can look at that to know is if I look here, 6 and 27, those both have a common factor of 3. So I could simplify that one some more. And let's say I do that, I'll write that in blue. So if I simplify this by dividing by 3, I would get 2 to 9, which we also see over here. So that's awesome. And 4 to 18 are even, so we can divide that both by 2. So that would be 2 to 9, which again we see over here. And so if you take a moment and you keep simplifying what you have, you can check and see, once you get to the end, that 2 to 9 can no longer be simplified. And if we look, we found that one, we found that one, and we found that one all the way across. So there are no other equivalent ratios that we could find here. Now we do still need to circle our simplest one. Boop, boop, boop. There is our simplest form. And as you can see by our Navy work, all those other ratios could simplify down to that 2 to 9. All right. State whether each pair of ratios are equivalent. If yes, you got to show how you know. And if no, change one of the terms to make it true. So I'm going to be looking for a relationship between these two ratios. And there's two ways that you can go about it. You can either multiply one up and see, is there a way that I can multiply 4 by something to make it equal to 12? And I know 4 times 3 is 12. So let's just see what happens if I do 9 times 3. So that would be 12 to 9. Oh, wait, that's wrong. Sorry, 12 to 27. And if you notice, that is our original, or our first ratio there. So yes. And this work right here, that would be sufficient to prove it. You could have also written this as fractions to know that 4 to 9, if I multiply that by 3, and I multiply that by 3, this would be 12 to 27. And so utilizing what we know about equivalent fractions, we could see that yes, these are related and they are equivalent. So over here, if I'm going to be looking at relationships between these terms, I know that 8 times 42, or 8 times 6 gets me to, no, that's a lie. Sorry. 4 times 6 gets me to 42. Well, if I multiply that 4 by 6, that means I need to multiply that 8 by 6. And 8 times 6 equals 48, not 42. So these are not equivalent. No. But we need to change them. So in my head, I'm thinking, well, 4, I'm going to keep that 24 to 42 because I like that. And since I know that this times 6 is 24, I need to figure out what times 6 is going to equal 42. And that is going to be 7. Now, again, if we wanted to think about this in a different way, we could think of these like fractions. We need 4 somethings to equal 24 42nds. So it's like you have a missing term in your fraction, or your missing denominator. And I know from equivalent fractions that whatever I do to the top, I would also have to do to the bottom. So the only number that could fit there would be 42 divided by 6, and that is 7. So there we go. We could change this 8 into a 7, and our ratio would be true. Now you could also say, I want to keep this 4 to 8 and keep my 24. So 4 times 6 equals 24. So I would need to do 8 times 6, and that would equal 48. So my other option is I could have 4 to 8 and 24 to 48 and just change this 42 to a 48. Whew. All right. Next, we have 8 to 36 and 4 to 18. Ooh, already I recognize that 8 divided by 2 is 4, and 36 divided by 2 is 18. So, yes, those ones are equivalent, and I have proven it. I could have also multiplied this by 2 to get 8 to 36. Either one of those would have been sufficient. Here we go. Now, when I look at this, I know 4 is not a factor of 18, so I can't just multiply straight across. And 18 and 36, those are not factors nor multiples. So if I'm going to figure this out, I need to simplify these two ratios to see, are they going to simplify down to the same simplest form? Well, 18 to 4, I know those are both even, so I'm going to divide by 2. And really, because the only factors of 4 are 1, 4, 2, and 2. And 18 is not divisible by 4. So my only option is 2 there. So 9 to 2 is our target ratio. Let's see. 63 and 14 are both odd, so we can't divide by 2. 14 and 63, well, we can't divide by 3. Can't divide by 4. Not 5. Not 6. What about 7? Ooh, I can divide this by 7. And I know 63 divided by 7. All right, is 9 to 2. Oh, check it out. So our 63 to 14 in simplest form is 9 to 2. And 18 to 4 in simplest form is also 9 to 2. So this one is a sneaky one, but the answer is yes. You just needed to manipulate both of them. Sweet.